Hey, welcome to our explainer. Today, we are cracking open a concept that literally builds fortunes and powers financial growth, all driven by a pretty simple algebra formula. Yep, we're talking about compound interest. And trust me, understanding this is like getting a financial superpower.
You know, when a mind like Albert Einstein's apparently calls something the eighth wonder of the world, you gotta pay attention. This isn't just about math class. It's a real financial force of nature that can either work for you to build your wealth or work against you, deepening your debt.
So, what's the big secret?
Well, it all comes down to this one key difference. With simple interest, your money earns a little something. Fine, but with compound interest, your interest starts earning its own interest. It's like a snowball rolling down a hill, getting bigger and bigger, faster and faster. So let's decode the formula that makes all this magic happen. Okay, to really use this power, we need a tool. And in algebra, that tool is a formula. Now, I know it might look a little intimidating when you first see it, but just think of it like a code. Once we break down what each little piece means, you'll see just how simple and logical it really is.
And here it is. This one equation right here is the engine behind pretty much everything in finance. Savings accounts, student loans, retirement funds, you name it. Each variable, each letter, tells a small part of your money's story. So let's break it down piece by piece. First up, we have A. Think of A as the answer, the final amount we're trying to figure out. It's the grand total you'll have at the end of the day, your starting cash plus all the interest it's earned along the way. Next up is P for principal. This is your starting point, right? The seed money. It doesn't matter if it's $100 you're saving or $10,000 you're borrowing. P is the foundation for the entire calculation. Now for R, the annual interest rate. Okay, listen up, because this is probably the most critical step. The formula doesn't understand percentages. You have to convert the rate into a decimal. So a 5% rate becomes 0.05. Get this part right and you're golden. N, this is where the compounding part really comes to life. It's just how many times per year the bank or lender calculates the interest. So if it's compounded monthly, N is 12. If it's quarterly, N is 4. And the more often it compounds, the faster your money grows. And finally, we have T for time, measured in years. And honestly, this is the real secret ingredient. The longer you let your money work for you, the more powerful that snowball effect becomes. So that's the whole code, right? Your principal grows at a certain rate, compounded a number of times over a period of time to give you your final amount. Simple. All right, enough theory. The absolute best way to really get this formula is to see it in action. So let's roll up our sleeves and run the numbers with a couple of real-world examples. Let's start with a really classic scenario. Say you invest $5,000 at a 6% annual rate, and it's compounded monthly for 10 years. First thing we do is identify our variables. So P is 5,000, R is 0.06, remember the decimal, N is 12 for monthly, and T is 10. Now, all we have to do is just plug them into the formula. And what do we get? Over $9,000. Just think about that for a second. Your money has almost doubled. More than $4,000 of that total is pure interest you earned by basically doing nothing. That, right there, is the power of compounding. So, you might be wondering, does that end value, how often it compounds, really make that much of a difference? Oh yeah, for sure. Take a look here. Same investment, same time frame, but when you compound quarterly instead of just once a year, you come out ahead. Now, it might not look like a huge jump here, but stretch that out over 20 or 30 years, that small gap can turn into an absolute canyon. And you know, the formula gets even cooler. What if you have a goal in mind and you want to know how long it's going to take to get there? Well, we can actually solve for t. To do that, we use another algebra tool called logarithms, which are basically designed to solve for a variable when it's stuck up in an exponent. It really shows how versatile this equation is. And for this particular problem, it'd take about 12.8 years. Now, this formula is incredibly powerful, but you have to be precise. There are two really common mistakes that can easily trip people up. So let's make sure you know exactly what to look out for so you can nail it every single time. Okay, mistake number one is, by far, the one I see the most. It's forgetting to convert the interest rate to a decimal. If you put the number 6 into that formula for 6%, your answer is going to be, well, just astronomically wrong. So please remember, Always divide the percentage by 100 before you do anything else. The second big pitfall is up in the exponents. You have to remember, it's not just t, it's a team effort. It's n multiplied by t. Why? Because that gives you the total number of times you're getting paid interest over the whole life of the investment. So in our first example, it was 12 times a year for 10 years, which means the exponent was 120, not 10. Big difference. Okay, so we've decoded the formula, we've practiced with it, we've dodged the common mistakes. But why does this matter so much once you walk out of the classroom? Because, and I mean this, it isn't just a random piece of algebra. It's a genuine financial superpower. Think about it. This single equation is the engine that drives all of these things. It's what makes your savings account grow while you sleep, but it's also the very same force that can make credit card debt and student loans feel like they're spiraling out of control. Understanding how it works, how this engine runs, is one of the most practical math skills you will ever learn. It puts you back in the driver's seat. And really, that's what this formula gives you. It's not just some abstract idea. It is literally a tool you can use to predict your financial future. Whether you're saving up for something big or trying to pay down debt, you now hold the key to understanding the forces at play. So the only real question left is, what kind of future are you going to build with it?